Hello friends, we are bigdatahandson.com. Today is day 33. Sorry, day 32. We are going to see recurrent neural networks using keras. Our website bigdatahandson.com. If you want to visit our website, you can visit our website. So if you have any doubts, you can message this in this number 978298844, or you can send email through support@bigdatahandson.com. So we have taken previously we have taken in machine learning, we have taken uh, nearly 15 sessions from day 15 to day 29, and Python videos also from day 4 to day 14 we have taken Python. And before that we have started uh, statistics and probability, 3 sessions we have taken. So all the videos you can find it in our YouTube channel bigdatahandson.com. So this is our channel. So here you can see we have uploaded the videos. I think till linear discriminant we have uploaded, so we'll upload as soon as possible. Okay, so today's topic is recurrent neural network. So let's jump into the topic. So as we know, all the algorithms in deep learning so are based on our human brain. Okay, so previously we have seen the artificial neural network and convolutional neural network. In both neural networks we have debit our human brain. Okay, so how the in our brain how the neurons is working, and how we classify the images we have seen right yesterday. So like that we have another type of neural network, that is recurrent neural network. In recurrent neural network what we does is we debit the human human brain in such a way how humans memorize something, like, so that's how we create a recurrent neural network. This will used for memorizing, like long short term memory, it's called LSTM. So we'll see that. Okay, so why not feed forward neural networks? Okay, in feed forward neural networks means normal artificial neural networks. So in normal neural networks you don't have any relations between the previous output and the next output. Okay, or you can say the current output. So we don't have any relation, output in the t and output in the t minus 1. So they don't have any relationship, right? So that's why to have a relationship, for example, if you are reading a book, you have to remember some few words before you study the current word, right? So then only you will understand what is the sentence. So like that you have to uh, memorize the previous outputs as well. Okay, so that's why we use the recurrent neural network to predict the output in the t plus 1. We consider these three outputs, the previous outputs, the output at t and the output at t minus 1 and output at t minus 2. Okay, so this independent of the previous outputs. Okay, and to overcome this challenge we created a new neural network like this. So in this neural networks you can see all the neural networks is depends on the previous outputs only. So you can see this neural network gives this output to the next neural network. In this network it takes the previous output and the current outputs as well, and calculates the new output, and this will be passed to the next output. So likewise we'll pass the current output also to the next output. Okay, to the next state you can say. Okay, so now the calculations will be like this, like so we have given the feature x0. X0 is the feature, and h naught is the state you can say, or the layer. Okay, so the y naught is the output of this layer. And to calculate this output h naught, so we have h of t, so h of 0 or h of 1, the time depends on the time, and equal to gh of the gh is nothing but the activation function you can see. Okay, and wi x of t plus wr h of t minus 1 plus bh. So here the wi x of t is the current output. Okay, So wi, the weight of this layer, and x of t. Okay, x of t is the current given input. So x of t is x of 0 now, and we are adding the previous outputs as well. To add the previous output, we have w arc, so the previous output weight, and the h of t of minus 1. So till now the h is 0. So the 0 minus 1, we don't have any layers on the minus 1. If you come to this layer h1, so now the t is 1, so 1 minus 1 0. So we consider the output of the layer 0, right? And then we'll add a bias. So this how we calculate the output of the layer. Okay, so like this it will become y of t is equal to gy wyh of t plus by. Okay, so this is the calculation for that. So in this recurrent neural network, usually we face two problems, that is vanishing gradient and exploding gradient. Okay, so what is vanishing gradient is? So vanishing gradient is nothing but whenever you are training a model, uh, first it will feed the input and it will calculate the output. Okay, so after calculating the output it will calculate the error, right? So actual output and the model output, that's the error. Okay, to adjust the weight, so based on to minimize the loss, that is error here, to minimize the error we adjust the weight. Okay, in adjustment, in the weight adjustment we will usually calculate like this. So w equal to w plus lambda w. Okay, so lambda w is nothing but here n into de by dw, so the derivative of the error we calculated. So the actual output minus model output whole square. Okay, so you when calculating the error, so the deviation of the error, if the deviation of the error is lesser than 1, very less value than 1, then there is no change in the weight, right? So if you add the lambda w also, it will same as the previous one, it will not updated. Okay, because the w is now very very less value, so there is no change in the weight. Okay, that's when there is no change, then we'll face the vanishing gradient, because the model will keep on training, but there is no updates, right? So that's the vanishing gradient problem. And exploding gradient is the opposite of the vanishing gradient. So when there is a huge change, okay, when there is a huge change, that's a problem for the problem of the exploding gradient. So the deviation of the error will be very very large value. Okay, so now the weight will be updated, a huge amount of weight will be updated. So that's the problem of exploding gradient. Okay, okay, so now we are uh, into the layer, into the recurrent neural network layer. So we use a recurrent neural network layer as the LSTM layer. Okay, so the long short term memory is the recurrent neural network layer. So you can see here, long short term memory LSTM networks are a type of recurrent neural network capable of learning order dependence in sequence predictions. So this you are seeing here A and this layer, and these are the LSTM layers actually. So you can see here the LSTM layers interconnected to others. See, so this layer is given an output. Now this layer is takes the previous output and the current output as well. Okay, and then it is calculating a new output, and then it's giving the new output to the next cell state also. Okay, so like this the long set of memory work. So inside the long set of memory, a layer inside this layer, you can see what is inside this. So we have some functions, and we multiply the values as well. So we are taking a this, it is called a cell state, and this is called a hidden state. Okay, and this now xt is nothing but the current input. Okay, input to the layer. And inside the a single LSTM layer, we have the sigmoid function, we have the TanH function. I said in the introduction to deep learning, I have said when we are seeing the TanH function, right? I said we'll use in the recurrent neural network. So now we are using the TanH function here, right? And we have using sigmoid function. So the cross is nothing but the pointwise multiplication here, and the plus means pointwise addition is the vector here. Okay, so in the recurrent in the LSTM layer, we have four gates. So the one is the first gate is the forget gate. So in the forget gate, what we'll do is we'll decide what information we need to keep, and what information we need to throw away. Okay, so that's the forget gate will calculate using the sigmoid function, because the sigmoid function, if you give now, so the output of the sigmoid function will be in between 0 to 1. So the closer to 0, that means to forget. So when there is a closer to 1, that means you have to keep the information. So that's what's explained here. So first we have the forget gate. This gate decides what information should be thrown away or kept. Information from the previous hidden state. So you can see we are taking the previous hidden state output and the current input, right? Xi, Hi, and Xi. So we are taking the two outputs, and current output it passed through the sigmoid function, and now the values come out between 0 to 1, because we are sending into sigmoid function, right? And then the closer to 0 means to forget, and closer to 1 means to keep. Okay. Okay, next we have the input gate. In the input gate, what we'll do is to update the cell state. Okay, so here is the cell state. So to update this cell state, we want some information, right? So to calculate that, we have the input gate. So we have the input gate. First we pass the previous hidden state and the current input into a sigmoid function. So first we are passing a sigmoid function, and also TanH function also. In the sigmoid function, it will give the values between 0 to 1, and 0 means not important, the information is not important, and 1 means that is important. Okay, and you also pass the hidden state and the current input into the TanH function also, to squeeze values between -1 and +1. And one more information, that is TanH function gives the values, the output between 0 sorry -1 to +1. Okay, to regulate the network, and then you multiply the TanH output and the sigmoid output. The two outputs will be get multiplied. Now this is the new cell state. Okay, this is the new cell state. We'll update the previous cell state with the new cell state. Okay, so the sigmoid output will decide which information is important to keep from the TanH output. Okay, so now in the cell state we have the third gate. Okay, in the third gate, what we do is we take the previous cell state and the current cell state, we update the previous cell state with the current cell state here, right? You can see here it is get addition, pointwise addition, right? So that means we are updating the cell state. Okay, now we should have enough information to calculate the cell state. First, the cell state gets pointwise multiplied by the forget vector. This has possibilities of dropping values in the cell state if it gets multiplied by the values near 0. Then we take the output from the input gate and do a pointwise addition. Okay, so you can see here. So we are adding pointwise addition, which updates the cell state to new values that the neural network finds relevant, then gives us our new cell state. Okay, so now the last gate is the output gate. In the output gate, we calculate the result, and we'll pass the result, actually the hidden state. So we'll calculate the hidden state, and we pass the cell state and the hidden state to the next layer. This is the output gate here. last we have the output gate. The output gate decide what the next hidden state should be. Remember that the hidden state contains information on previous inputs. The hidden state is also used for predictions. First we pass the previous hidden state and the current input into a sigmoid function here. So the previous hidden state and the current input to the sigmoid function, uh, and then we pass the newly modified cell state to the TanH. So we pass the cell state into the TanH, and we multiply the TanH output with the sigmoid output to decide what information the hidden state should carry. The output is the hidden state. The output of this layer is the hidden state here, and the new cell state and the new hidden state is then carried over to the next time step, so the next layer. Okay, so this was all about the LSTM. So now we'll see the implementation. So to do that I'm going to use the collaboratory. uh, okay, so for that I will go to the my drive first. So now we'll create a new collaboratory notebook using the new button right here. Click on the new button, or else I will use the untiled here, is empty actually. We'll use this. So for today's session I am going to use a data set from the Kaggle. If you want the data set you can download it from Kaggle. So the data is the Google stock price prediction. Not only Google, we have many more companies. So you can go to the data tab here and search for stock price prediction, and you can get it the huge stock price prediction you will get. And there you can select whatever company you want. I think this will be here, not here. So you can search it. Yeah, here Google stock price. Yeah, huge stock market data set. Here you will find all uh, the stock prices of all the companies here. So from here you can select whatever you want. The data set is the same dimensions, all the data set. So it has a date column, open, high, low, close, volume, open, int. Okay, so we are going to predict the stock price in the when closing the market. Okay, so that's what we are going to do. What is this? Oh, this is used actually. So we'll create new one. So now you want to connect it to the environment. uh, One more quick reminder. So in the runtime, collaboratory gives you GPU processors and TPU processors also. So that means you can connect with the GPU runtime or TPU runtime. Okay, you can see none. It means user is connected with the CPU. So if you want good performance, you can select the GPU or TPU. Okay, GPU is graphical processing unit and TPU is tensor processing unit. Okay, so first let me connect to the CPU, and after creating the model, we'll try with the GPU. So now then it connected to the environment. So what I'm going to do is I'm going to upload a file here. So the data set for the stock price prediction from my local machine. So it has two data set: stock price, Google stock price test, and Google stock price train. So the two data sets is uploaded. Now what we need to do is we need to import the libraries first. We'll import it, the pandas, numpy, and matplotlib. So now we're going to read the data set. Let's name it as dataset underscore train because we have two files. So I name it as dataset train, and I'm going to read the dataset using the read CSV function. You need to give the path of the file. So to get the path of the file, you can click here. You will get the copy path. Oh, sorry, that's a test for. Okay, we'll copy the path for training data and we'll paste it here. So now if you run this cell, you will get the data set. If you want to see, you can see like this: dataset train dot head. Sorry, not zero. So the first 10 observations is given. So you can see here we have date column, open, high, low, close, volume, like that, right? So what we're going to do is we are going to take this column only, the close, when the stock price when is in the closing, right? So to take, I will create a variable train set, training set. Okay, now in the training set we'll have the data set underscore train. I'm going to select the column. So all the rows we want, but the column is 1 column 2. That means we are going to select, oh, we'll select the close column. Sorry, not 1 column 2. So the number of the index is 0, 1, 2, 3, 4, 4, right? So we'll select 4 colon 5 will give. So why I'm giving 4 colon 5 is because if you give only 4, you will face a problem of reshaping. You want to reshape with minus 1 comma 1. So to not to reshape like that, you can put colon 5 here. So that means it will give you uh, multiple rows, single columns. So like that it will give you. So and we can convert it to numpy arrays. Okay, now you can see that. So you can see multiple rows, single column, right? So this is how the data sets we want, the shape of the data set. And after getting this data set, what I'm going to do is I'm going to scale the data set in the neural network. In the neural networks, we usually scale the data set using the normalization, not the standardization. So I have said before, what is standardization and normalization, difference between the standardization and normalization. So standardization usually takes a different scale, right? For every data set it will be different. So it can be -1 and +1, it can be -2 to +2. But in the normalization, every data set the same scale, 0 to 1. Okay, so that's what we are going to do here. In the sklearn library pre-processing module, we'll import the, not the standard scalar. Now this is the min max scalar. Okay, here you have to create an object for the min max scalar, and we'll give the feature range as 0 to 1. Okay, and then we'll fit the min max scalar into our training set. Fit underscore transform. Sorry, I forgot a. What is this? Could not convert string to float. Why? Oh, it's a D type object. Okay. Oh, the close is an object actually. You need to convert it to string to integer. But this column are float 64. I think we can use the open. Okay. So to use the open is the index 1. So you can give 1 colon 2. Otherwise, if you want to use the close, what you can do is uh, you can convert the type actually. I think you can convert the type. Okay, so we'll select the open column. Now that's a float 64. Okay, now it's working. Okay, so now we scaled the data set. Now what we are going to do is we are going to separate the data set into training and testing. But we don't have any, sorry, we don't have any y variable, right? We have only the dependent variable. We don't have any independent variables. So to do that, what we are going to do is in this data set we are going to uh, separate the data set as this time steps. That means we'll select the first 60 observation as the as the x variable, and the next of the day, that is the y variable here. So so we'll take the previous 2 months data set and we'll predict the next day. Okay. So based on the previous 2 months data set, so that means 60 days, right? 60 observation means 60 days. So 2 months, 2 months of the data set will predict the next day. Okay, tomorrow what is will be the stock price. Okay, so like that, to create we have to split the data sets as the time steps. So we'll take the x train, to list will take, and y train. So in the x train we'll okay, so we'll run a loop. So for I in range, so what's the size of the data set? Yeah, 1258. So we'll start from 60 because we are going to separate the data set at 60 time steps. So from 60 to 1258. Okay, sorry for I in range. Now in the extrain I'm going to append the data. So the data is extrain dot append. Here I'm going to select the data set from the training set. From the training underscore, sorry, training set, I'm going to select. So now this is the array, right? So you need to give the rows and columns. So the column is 0, we know that. So we have only one column, right? So but the rows I'm going to select is it will be different. So we'll start it from the I minus 60 colon I. So what does this mean is, so we are starting from 60, right? So what happens, I is 60 now. 60 minus 60 is 0, and from 0 to 60, not 60, 59. Okay, so from 0 to 59 is the first set. Now first time step. For the output of this time step will be the 60th data, right? 60th observation. From 0 to 59 will give us a x data set will take, and for the y will take the 60th data. So I comma 0, that's it. Okay, so the output of the 0 to 59 data set will be the 60th data. Okay, so this how we'll create the time steps. After creating this time step, we need to convert into arrays, right? So we can convert xtrain comma ytrain equal to np dot array. Okay, so now we have the data set. Now what happened? Training set is not, oh, oh, sorry, I forgot to put R here. So now we have the data set. If you want to see, you can type xtrain. So you will see here, so you can see this time steps, right? So it's the first time step, this is the second time step. Actually this is the last one, it is skipped now in the middle. So every time steps has 0 to 59 60 values. Actually this has the 60 values, and this time step has the 60 value, this time step has the 60 value. Okay, the output of the 60 observation will be in the white train. Okay, so the stock price after these 2 months, the output will be this one. Okay, okay, now we got the data set. It's time. Now in the extrain, actually we want to reshape the extrain. In the extrain, you want to reshape such a way like the RNN will understand, the LSTM will understand. So the LSTM takes the data set in the 3 dimension. So I'm going to reshape the data set. So to convert into 3 dimension, it's very simply, you can use the reshape function, np dot reshape. In the reshape, you have to give the array, that is extrain here, and you have to give the dimensional. So the dimension I'm going to give is extrain dot shape of 0. We'll keep the shape of the extrain, but we're going to add a new dimension. So that is here I'm going to add comma 1. So now this will become three dimension. So we are adding a new dimension here. Okay, so now what happens is it will create a windows like 60. So now the extend dot shape of 1 is the 60. Okay, so now 60 comma 1 is the dimension of the window. Now how many observations we have? Extend of shape of 0 observations we have. Okay, okay, now we are reshaping it. Now you can visualize that it will be a little bit different than the previous one. So you can see it is different, right? Yeah. So we are added a new dimension. You can see 1 2 3 right here. So now this will become 3 dimension. Okay, so now let's move forward. Now we pre-process the data set. We have the data sets as the LSTM will understand. Now it's time to create the neural network, the recurrent neural network. For that, I'm going to import some classes from the keras library. Keras.models. I'm going to import the sequential model. Okay, and some other layers as well. From the keras.layers, uh, we're going to import the important layer, that is LSTM now. So using the LSTM only will create the recurrent neural network. So that's here. And again we have the dense layer as well. For the output layer, we'll use the dense layer. And another layer also I will import for regularization. So to regularize the neural network. So why we are using the regularization is because not to overfitting. Okay, because of the overfitting, to avoid the overfitting, you use some regularization layers like dropout here. Okay, dropout is actually a regularization layer. Okay, so now we'll create the model sequential. Okay, so we'll add a layer model dot add. We'll add the LSTM layer. So in the LSTM class, it takes some parameters. So that is units of the next layer. Let's give 40 here. Okay, some randomly, or we can give the half of the data set shape, that is 60 half 30. So we can give 30 maybe. And now we're going to give the input shape. Okay, input underscore shape. Input shape will be the shape of 60 comma 1 actually. So you can give 60 comma 1, or you can take the dimension from here using the array, or you can take. Okay, but we know that actually we are doing 60 time steps, so we can give 60 comma 1. Okay, and you have to give return sequence. So whenever you are giving return sequence, that means you're going to have another LSTM layer after this layer. So it will prepare to pass the hidden state and the cell state. Okay, because for every layer we are passing the hidden state and the cell state, right? So this is the LSTM layer. One LSTM layer will have one or more LSTM layers, then it will pass the cell state and the hidden state. Okay, so I'm giving return sequence equal to true, and here I'm going to add a regularization layer dropout with 0.2. That means what happens in the dropout is, in the dropout layer, what it does, let's say you having 10 neurons. Okay, 10 neurons in your layer. So if you pass 0.2, that means 0.2% neurons will be deactivated. So in the 10 neurons, 2 neurons will be deactivated randomly. Okay, so this avoid the overfitting. Okay, so let's add uh, 2 more LSTM layers. Okay, so now we have 3 LSTM layers. Here in the last layer, we'll remove this one also from these 2 cells. Okay, so now we have 3 LSTM layers. Okay, so if you confirm that is we are going to use 3 LSTM layers, you can remove the return sequence from the last layer. Okay, so we'll remove the LSTM return sequence from the last layer, and we'll add the output layer. So that is dense of units equal to 1, because we are having only one output. Okay, so now this is the regression problem. So in the model dot compile, you have to give a different uh, loss function, that is mean squared error. So the loss function loss equal to mean squared error, mean underscore uh, squared underscore error. Okay, and we give the optimizer as Adam. Okay, now we have to fit the model into the dataset, training dataset x train comma y train, and we give the epochs, number of epochs. Let's give the number of epochs 50, and we'll give the batch size uh, batch size will give 30. Okay, what's the problem? Return sequence, okay, misspelled I think. Oh, return sequence or return sequences, maybe. Return sequence. Yeah, return sequences. Okay, that is return sequences. Okay, so now the epochs is running. It started training the model. It takes long time because we are using the CPU. If you want, you can connect to a GPU environment. See, you can see the loss is decreasing, right? That's what we want. If you want to see the accuracy, you want to add a parameter, that is matrix here. Matrix equal to you, in the list you have to add the accuracy. Okay, so I will stop the training and I will connect to the uh, GPU environment, and then we'll run the training. Okay, so I can give an matrix accuracy. Okay, so we'll change the runtime to a GPU save, and this will reconnect the environment. After reconnecting it, so you will see no files is here. So it will when you are reconnecting to the environment, the files will be deleted. So you want to upload another time. So here, okay, what we'll do now is we'll run all the cells, run all. Now we'll come to the, yeah, so it will start the training. So it will be very fast now because it's a GPU. So as you can see here, it is running fast, right? So our main intention is to reduce the loss here. Don't worry about the accuracy. Yeah, now the 50 epochs is completed. The final loss will be 0.0023. So now it's time for the prediction. So for the prediction, you have to do you have to read this file, right? Test dataset. Yeah, here Google stock price test. So we'll copy the path, and here we say dataset underscore test here. Okay, now this is a test dataset, and we'll read the file read underscore csv, and we'll give the path here. Okay, now we have the dataset test. Here you want to select the column. Let's name it as testing set. In the testing set, we will select the column from the dataset test, not train, it's a test. Or you can see that's the real price, right? Real data or actual. So we are going to predict for this data only. Okay, so now in this test data set, we'll select the column comma 1 column 2. So we are selecting the open column, and we are converting into the values arrays. Okay, that's it. And now what I'm going to do is, what is this data, this test? Okay, so we got the data set test, and we got the actual values from the testing data set. Now it's time for prediction, right? So you have to create the training set, sorry, testing set, like we have created the training set. So like the time steps. Okay, so time step you want to create for the testing data also. For this we have some codes here. It will be very confusion, so I will explain to you here this part. Okay, one by one I will tell you. So here what we are going to do is, actually we have read the stock real stock price data set test, and now we are going to create the data frame, that is data set total. That means we are going to add the test and training both. Okay, this variable will contain the whole data, that is training and testing. That's why we are concatenating the both data set training and testing, the column open column. Okay, and we are giving access equal to 0. That means we are going to concatenate with the rows, not the columns. We are concatenating with the rows, and we are going to take the testing inputs. So these inputs variable is nothing but inputs for testing. Okay, to prediction. Okay, and we are going to select the inputs from the dataset total, and we are selecting the rows which are going to use is this one. So it will be uh, very a little bit confusion, because you can see here len of dataset total. Okay, so the total length of the dataset, and we are subtracting with the data test. Okay, data test is the size of the test dataset, and we are subtracting minus 60. What this will do is, we'll select the data set from the previous 2 months. Okay, so now we have the data set test here. It will start from, let's say, from today. Okay, for calculating, for prediction of the today's data set, we want previous 2 months data set, right? So to calculate the today's stock price, we want previous 2 months. So that's why we are selecting the previous 2 months also. Okay, that's why we are subtracting the test data set with the total number, and we are subtracting the minus 60 also. Then you will get previous 2 months results also. and after getting that we'll reshape it to -1 comma 1, and we'll uh, apply the min max scalar. Okay, after calculating the inputs, now it's time to create the windows or time steps, 60 time steps. So to create that we have these lines. This will create the 60 time steps. Okay, now we have the x test. The range is between 60 to 80. That why the 80 is because the size of the inputs you can see here. Inputs dot shape. So you can see 80 comma 1. So we have 80 rows, right? So that's why we are giving 80 here. So we are selecting the 60 time steps over the 80 data set. Okay, and the same as what we done before for the training set. Inputs I minus 60 colon I comma 0. Okay, now this will give you the testing data set. Using the testing we are going to predict using the model. Okay, we are going to pass the test data set. Okay, so now what we'll do is we are going to predict that test data set. So before you want to convert the testing data set, it's a list here now. So you want to convert into array. After converting the array, what we do, we need to reshape it. That's the LSTM will understand, because the LSTM takes as the three-dimensional data set. So now to convert the three dimension, you have to reshape the test data set like this. Xtest dot shape of 0 and xtest dot shape of 1 comma 1. So we have done before for the training, so the same we are doing here. So here we have seen, right? So the same step we are doing for the test data as well. After converting after reshaping the data set, now you can give the model to predict the x test. Now this is the predict the stock price. Okay, so now we have applied previously, we have applied the standard scalar, sorry, min max scalar, right? To inverse transform, to get the original value, you want to inverse transform that. Okay, so AC dot inverse transform of the predicted stock price. Now we'll run this. Okay, now we got the predicted stock price and we have the actual value as well. Actual here and predicted here. So now we will create a plot. We will visualize the predicted and actual here. So not the real stock price, that is actual. Okay, actual and predicted. So this is the plot for the actual and predicted. So this is the real stock price and this is the actual price. So it will not be more accurate. Okay, so to make accurate, you want to train more epochs, or you can add another LSTM layer. Let's try with another LSTM layer, or you can change the units. So like you want to tune the parameters to get more accuracy. Okay, now in the runtime we'll run all again. Yeah, now we have the minimum loss 0.22. So now you can see it's a little bit accurate, right? Okay, so this is how the LSTM RNN neural networks will work, recurrent neural network. So you have any doubts, you can ask now. We'll end up this session from this. Any doubts you have? Okay. Any doubts? Okay, so we are bigdatahands-on.com, our website bigdatahands-on.com. If you have any doubts, you can message this number 978988844, or you can send email through support@bigdatahands-on.com. Our videos will be uploaded as soon as possible in our YouTube channel bigdatahands-on.com. You can see our videos. Okay, so let's see tomorrow. From tomorrow, we'll see the same ANN and convolutional
Hello.
recurrent neural
Hello,
networks
sir.
using the TensorFlow. Yeah,
Hello. Sir, can you
yeah.
share these notes to
The
notes?
notes, the
Yeah.
notebook.
Yeah. Not notebook. Notes. You are uh, creating the programs, no? That documents also I need, sir.
Documents we can't share.
Documents you all already
You want?
explained from the beginning of the topic, no? That document I need.
Uh, I can't share the slides actually, but if you
Uh-huh.
want, I can share this code if you want.
Okay, okay,
Okay,
okay, sir. Okay.
okay.
Sir, where I get this documents, sir? I mean,
Uh,
presentation document.
yeah, contact Kaleel.
Okay, okay, sir.
Kaleel sir will give you.
Okay, okay. Thank
Okay, okay. So we'll see tomorrow. Tomorrow we'll see the TensorFlow. Okay. So we created the models using the keras, but tomorrow we'll use the TensorFlow. Okay, bye.